Good day everyone. We are here to tackle about integer programming in chapter 5. In the linear programming models formulated and solved in the previous chapters, the implicit assumption was that solution could be fractional or real numbers, that is non-integer. However, non-integer solutions are not always practical. When only integer solutions are practical or logical, it is sometimes assumed that non-integer solution values can be rounded off to the nearest feasible integer values. This method would cause little concern if, for example, x sub 1 is equals to 8,000.4 nails were rounded off to 8,000 nails, because nails cost only a few cents apiece. But if we are considering the production of jet aircraft and x sub 1 is equals to 7.4, jet airliners rounding off could affect profit or cost by millions of dollars, because jet aircraft is big production than the nails. In this case, we need to solve the problem so that an optimal integer solution is guaranteed. In this chapter, the different forms of integer linear programming models are introduced. What is integer programs? A linear program plus the additional constraint that some or all of the variables must be integer valued. There are advantages and disadvantages of restricting variables to take on integer values. Advantages: more realistic and more flexibility. And disadvantages: it is more difficult to model and can be much more difficult to solve. Integer programming models. There are basic types of integer linear programming models. First is a total integer model. Second, a 0-1 integer model. Third, and lastly, a mixed integer model. Total integer model. All the decision variables are required to have integer solution values. 0-1 integer model defined all the decision variables have integer values of 0 or 1. Mixed integer model. Some of the decision variables, but not all, are required to have integer solutions. Total integer model example. The owner of a machine shop is planning to expand by purchasing some new machines, presses, and lathes. The owner has estimated that each press purchase will increase profit by $100 per day, and each lathe will increase profit by $150 daily. The number of machines the owner can purchase is limited by the cost of the machines and available floor space in the shop. The machine purchase prices and space requirements are as follows. Press is occupying a 15 feet squared and a price of $8,000, and lathe is occupying a 30 feet squared and a price of $4,000. The owner has a budget of $40,000 for purchasing machines and 200 square feet of available floor space. The owner wants to know how many of each type of machine to purchase to maximize the daily increase in profit. The linear programming model for an integer programming problem is formulated in exactly the same way as the linear programming examples in chapter 2, 3, and 4. The only difference is that in this problem, the decision variables are restricted to integer values because the owner cannot purchase a fraction or portion of a machine. The linear programming model follows: maximize z is equals to $100 x sub 1 plus $150 x sub 2, subject to $8,000 x sub 1 plus $4,000 x sub 2 is greater than equal to $40,000. 15x sub 1 plus 30x sub 2 is greater than equal to 200 feet squared. X sub 1, x sub 2 is less than or equal to 0 and integer. wherein x sub 1 is the number of presses and x sub 2 is the number of lathes. The $100 is described as the increased profit of press per daily, and 150 is described the increased profit of lathe daily. The decision variables in this model are restricted to whole machines. The fact that both decision variables and can assume any integer value greater than or equal to 0 is what gives this model its designation as a total integer model. The next reporter will introduce to you the other models. Thank you for listening and God bless you.